Welcome to Model Steam Engines Top Tip Time Part 63. Once upon a time, most miniature steam boilers used in model boats were of the centre flue cross-water tube type, fired with a very ferocious petrol or paraffin blowtorch. These days things have changed. Now most boilers are gas-fired. This is a ceramic type of burner, and this one was taken from an early Cheddar Models fire tube type of boiler, which work with ceramic burners perfectly well. This is a very common fuel source for model steam engines these days. It's 70% butane and 30% propane, just to give it a bit more pressure. The following video compilation explains it much better than I can do here, and a lot of people should find this very useful. Welcome back, my friends, to the show that never ends. Most gas burners for model steam boiler applications are designed to use this type of gas. It's a 70-30 mix of butane and propane. In some applications there's a separate gas tank that you fill from the larger canister. But in this demonstration I'm using one of these. It's a commercial gas canister adapter, fitted with a removable long pipe, and on the other end of it is a gas jet. This is a number 8 gas jet, and it's fine for the smaller types of burners. You may have noticed that the holder is a bit chewed up. That's because I've fitted this part and clamped it in place quite a few times. The gas jet is going to go into this burner, which I recently bought from a company called Forest Classics. I've bought a few of these over the years, and they can prove difficult to use, assuming the gas jet is the right size, and a number 8 is on the top end for this size of burner. This burner is going to be used in a Stuart 500 boiler application. The one behind it is the larger type for a Stuart 504 boiler. In this clip I've set it so you can just see the nozzle of the jet through the hole in the Venturi pipe, and now it's lit and burning nicely. If I push the gas jet further into the Venturi pipe, the ceramic doesn't glow quite as brightly. But if I move the gas jet in the opposite direction away from the burner, look what happens. The ceramic is being overheated, and the burner starts to make a quiet roaring sound which will eventually get really loud, at which point you must turn off the gas. When these burners are in use, they really should be silent. You can of course reduce the gas pressure. The problem with that though is the burner is much more likely to blow out, particularly if you're using it outside when it's breezy. For this experiment I have the gas tank valve fully open, and look at the state of the ceramic now. It's really starting to get hot, and the roaring noise of the gas is getting louder. If you just bought one of these burners, I do not recommend that you try doing this. The whole point of this video is to show people how not to cremate their Bix burners. This burner is reaching this temperature sat on a piece of wood on my workbench, and if the burner was inside a boiler casing it would get much hotter very quickly. When I turn the gas off you can see just how hot the ceramic is. It takes quite a while to cool. I let it cool and relit it. This time I've pushed the gas jet further into the Venturi tube, and as you can see it's not quite as bright, but I still think it's a little bit on the bright side. I once read a Bix burner instruction leaflet, and it said you should aim for lots of little blue triangles above the burner. This is much better. It's not overheating, and the burner should run all day long at this temperature. This clip clearly shows how far the number 8 jet is pushed into the Venturi. I'm going to try this same number 8 jet on the larger burner for a 504 boiler. It's a bit on the small side. I think these larger burners are designed for a number 10 jet, but it's burning this piece of wood quite well. And as you can see, I have the gas jet pushed quite a long way into the Venturi tube. I'm going to revisit this MaxSteam ceramic burner. This particular burner was taken out of a MaxSteam boiler because it kept overheating. I spoke to Mike Abbott about this, and he said it was the type of ceramic he was using. This is very similar to the ceramic that's used in Bix burners, and they're also prone to the same problem if the position of the jet is incorrectly set. As suddenly the flame sucks back inside the burner and burns inside the burner and cremates the ceramic. So I changed the ceramic for a type that Mike Abbott used to use in his early burners. If you compare that earlier type of ceramic with the ceramic in these Bix burners, you will see that it's quite different. This type of burner does not replace a coal fire inside a firebox of a model steam boiler. But on the plus side, these are a lot cleaner. When I turn out the lights in the workshop, you can immediately see how much better this is. Can you see the small blue bits? That's the way it needs to be. The burner must not be a continuous red like this, because it will just burn out. You can tell the difference just by the sound alone. So this is where you need to be. You need to have some blue bits on top of the burner. A really annoying problem with water tube type boilers is known as howling, and this problem is twice as bad on a twin flue boiler. A resonant frequency is set up down the flue, pretty much like a flute. I love the sound of a flute, but I don't like the sound of boilers howling. Here is a good example of what I mean. And almost immediately the howling commenced. But once I turned down the gas pressure to low, it disappeared. What you're about to see is an interesting idea which was sent in by a viewer. I've turned off the gas and I'm removing the burners using a cloth because they're very hot. The viewer suggested putting some sound absorbing and fireproof material into the flues. This is ceramic wool. I do have some thinner stuff somewhere, but I couldn't find it. This may be a bit thick. Thinking about it, it is a good idea. I fitted the ceramic wool and relit the burners through the hole in the front of the boiler. To be honest, I am not a big fan of these twin flue boilers. I do not like lighting that much gas in a confined space. One of the burners actually went out. I had to relight it. And after the bang, I clicked the lighter a few times to make sure that it was fully lit. The ceramic wool stopped the howling, but it also stopped some of the heat from getting through. Maybe some thinner ceramic wool would do it, but I don't have any of that, and I'm duty bound to keep this boiler as it was designed by the manufacturer. I thought I'd have a quick look at the state of the fire on the burners on the bench, and everything looks quite good. So I turned the gas off, refitted the burners to the boiler, then I relit the boiler one more time, and now I'm raising steam. Quite a while ago I made a series all about gas burners. It was in 3 parts and it's called The Quest for Fire. Here are some extracts from part 1. The size of jet fitted to this burner is a number 8, and that's the one that I found to be the best. And as you can see, it's connected to a little gas tank, and what I have to do is simultaneously turn on the gas and hold an igniter over the chimney, and you saw it flash there, which means the burner is lit. And problem number 1 immediately occurs, the howling. If I withdraw the burner, it stops. If I push the burner back into the flue tube, it starts again. I tried various experiments to make them stop the howling. The howling is a resonant column of air in the tube, like a musical instrument. I found that if I blocked at one of the primary air holes, often the howling stopped. So then the idea was to fit a ring that you could slide up to partially cover the air hole, and that worked. Mike started fitting these to his boilers, and they definitely worked okay. They shut the howling up. But there was a trade-off. Incomplete combustion. Insufficient air equals incomplete combustion equals a really foul smell coming out of the chimney and possibly carbon monoxide. If you move the ceramic burner away from the boiler's flue tube, obviously the howling stops, because there isn't loads of air rushing in and being accelerated over the small openings in the burner. Once the gas pressure drops, which it does very quickly as the tank chills, the howling tends to disappear, but so does the heat. It took quite a while before I got any steam at all out of this boiler. I think it was possibly about 25 minutes. Mind you, this is a very small ceramic burner, but eventually it started producing steam. Not a lot of steam, may I add, but steam nevertheless. I connected a piece of silicone rubber piping onto the boiler's steam outlet and connected the other end to a Cheddar Models puffin. And after a while longer, once the pressure built slightly, the little puffin engine ran very well in both directions. I'm going to make some more videos all about gas burners. As usual, addressing the howling problem and at the same time attempting to get more heat out of ceramic burners in model steam engine applications. But that's it for now. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.